I'm gonna share the screen. All right, so it's recording. Oh, yeah, sorry. All right, so it's recording. Let's go to the the VM. Okay. All right, so we're gonna go over this one. I did find a way of making it binary also. So there's a couple of ways that you could have solved that problem. But I'll show you. Okay, so let's start the terminal. All right. Let's go to the desktop. Right, so remember what we're doing is we did one example of writing an algorithm in Python from scratch, and it was a substitution encryption. Okay, substitution is pre-1940s, so it's basically a substitution cipher. If you remember, 26 was A, 25 was B, something like that, right? So we went over that algorithm and we basically did encryption with it and decryption. And then we saw what's important there is that it's not a secure algorithm, even though it can be a little bit tough to understand. Second algorithm we did is now using XOR. So if you remember, we went over the theory and we said that XOR is a major operation in a lot of encryption techniques, right? And so I gave you the code to do that in Python, right? So you have that as well. And then we'll do several, a few algorithms this semester building on top of that operation of XOR, okay? So the easiest thing that we can do with it is to implement a hashing algorithm. Now, the great thing about a hashing algorithm is we don't need encrypt and decrypt, right? We only need to go one way. So we go from encrypt, so we encrypt and create one block. So if you remember, we defined that hashing is basically taking something big of variable length and converting it into something fixed of shorter and of fixed length. Okay, that's kind of what it is. So basically, if we have a sentence or a paragraph that's 20 blocks of size 8, we use an algorithm to take all of those and just produce one block of size 8, and that's the hash value, or it could be 16 and so on. And we just use the XOR operation. So we went over the very simple algorithm where we took a document, broke it into blocks, and then just XOR all of the blocks until we arrive at a final block, right? And then that's your hash. It's as simple as that. And that is the algorithm that we were implementing last week, and we're going to finish that up today. So let's go ahead and go to the folder, and it's going to be an XOR. So I'm going to do, oops, clear. All right, so the algorithm is hash XOR. I'm just going to create a copy of it because that one I already solved. And I'm just going to call it hash XOR 2. Just to kind of, so I'm going to delete some things. .py. All right, so I have 2 scripts in there. So now we're going to work on the hash XOR. So I've already loaded like the first video of this, part A, so you can find that. Remember, you can always look by the date of when the class took place and find that particular video. So I usually load videos either the day or the day after. Okay, so let's go over. Thank you. Let's go over the script and try to finish it up. So hash XOR 2.py. So I'm actually going to run it first, just so that you guys see kind of the output. And then we're going to work through it. All right, so if you see, that's basically the process. I kind of tried to print out everything that was relevant. So this is a top secret 1 through 90 and then A all the way to Z is basically the message that we are trying to hash. Remember, hashing only involves encrypting in one way here, right? We said that we wanted the block to be, I think, the blocks be of size 8. So we hard-coded that in the code. And so that allows us to break the message into blocks of 8. You can see that there. We did that. The last one, YYZZ requires padding. You can see it's got padding, which is basically spaces. And then, as you can see in the process, I did a for loop where I'm taking the string, and you can see that these are changing. You see how the hexes are changing? They're being basically, I start with like a key, and I take the first block, XOR it. That becomes the new key, if you will. And I take the next string, XOR it. That becomes the new key. And I keep doing that until I arrive at the last one, which is this one. And that's the hash, basically, of XORing all the blocks. Here, I just made it nicer looking, right? And then finally, the binary approach. Now, if you guys wanted to, this is not homework, but if you felt like doing this, you could actually start at the beginning, convert everything to these binaries, right? And then convert them into integers, do the caret operation, and then you could do it. I think you wanted to do it this way, right? So you could actually write your own algorithm where you're doing it kind of how we did it by hand, like the math approach. Does that make sense? So we could do that because you can always take the hex and do it like that. So that's something you can do if you'd like, but I'm not making it required. Instead, I just kind of showed it at the end. So that's this one. I just did it twice, but it's the same one. All right, and that's the binary representation. This is the hexadecimal representation, but that's basically your hash value. This one is more consistent with, I think, what we did in OpenSSL, right, where you were sending something like that to your friend. Okay. All right, so that's the script, basically. And now we're just going to go through it and how it works. So let me go into the Nano editor. Okay, and we had done pretty much everything except this part. So I'm going to just delete this, and we'll do it again. It'll allow me to type it up slowly. So I'll just leave it as, found. All right, so this is everything else we had done, okay, last week. I'll review it, and then we'll pick up here, and that will be, the part B, okay? Any questions? No questions? All right, so I'm gonna just save this so I don't lose it. Go back to it. Okay, so if you remember, the logic was, we spent a lot of time on creating the blocks, right? So we created this function, create blocks. Okay, actually, some of the code that we use here was similar to the substitution code. So they were consistent, if you will. So the logic is, let's go for the main section, right? We start with a plain text, which is this one. This is a top secret, but it's a long message. And so what we do is we break it into blocks, okay? These are all block ciphers, okay? So symmetric key encryption. We're kind of wrapping up this idea, but we will come back to try to implement this later in the semester. All right, so we print out plain text. Then we decided that the size of it is 8. That's just a choice. 16 could have been another number. And then we measure the length of this, which was, I think, 84 letters. So then we had this function called create blocks, where we give it the actual plain text and the length, right? And so what we do in create blocks is basically we take the string and, grab the chunks. Every 8 letters becomes a chunk, and we created a list, okay? We went over this last week in a lot of details, so I'm not gonna go over all the details, but created a list here, right? Then a for loop from 0 to the length, and we have a step size, okay? And that allows us then to kind of, every iteration, we grab from 0 to 8. That's one block. Then the next one, 8 to 16. That's another block. Then 16 to what, 24, and so on, right? And now we create a list of these objects, okay? But we had a little bit of a problem, right? So we want to measure the size of the block. For all in the beginning, they're all going to be size 8. But the problem is the last one may not be of size 8. And so we're going to have to apply padding, all right? And that's what this if statement is for. So we check if the length of block equal block size, so that is to say it's size 8, then we just add it. If not, then we need to do padding. So for that, we just take block size minus the length of the block. Let's say the last block has 4, but the size is 8. So that would give us 4 here. And then we just added spaces, 4 spaces, basically. And now we padded it. And then just add it to the block. That's pretty simple, right? And that's the function for creating the blocks. Any questions? Very easy. All right, good. So now I wanted to reuse what we had done in the XOR. So actually the encrypt function worked really well for this. If you remember, that encrypt function takes a block and a key. The block is a string, the key is a byte array, XORs them, and we get a new cipher. And so we can use that approach to basically create the hash, right? So that's the idea here. So we created gen key of size 8. That's this one. So size 8 gen key. We already talked about gen key. We'll use gen key quite a bit. All right. So we'll use it again when we do des. So just remember how it works. Remember, we create a byte array of size of random values of length 8. And basically that gives us the key. So now we have a key of size 8. We just printed the key, we printed the list of blocks, and then that's it. And that's takes us to hash function. And this is the last thing where we kind of like left off. So what does hash function take? It takes the list of blocks, right? And it takes the key that we generated, okay? So of size 8. So what this produces is basically one block of size 8, which is the hash value after doing all the XORs. So we're going to take all the blocks and just XOR it with the next block and the next block and the next block and just have one final block. Got it? All right. So let's take a look at hash function, right? That's the function that we didn't define here. Okay. Everything else has already been discussed. Encrypt I didn't change it, is the exact same encrypt we had before. Notice, remember, the caret does the XOR operation between the plain value and the key, okay? So every time we use encrypt, we give it a block of 8, right? That's plain. And the key is also of 8, so we just XOR each one, okay? So that didn't change. And we don't use decrypt for this because all we want is hash values. So now we're going to write up hash function, okay? And you'll see it's actually short enough. So the idea is that we're going to iterate through, so 1, 2, 3, 4, right? So we're going to encrypt, so 4 block in list of blocks. Okay, so we grab every single block and we just XOR them together, okay? And what that's going to give us is one final block of everything. And since we're always going to repeat the same procedure, right? When we do it again, it should give us the same block again, assuming we use the same key. That's why you have to send this key to your friend, right? So this is a keyed hash. Now, that's one of the things that we'll see in the homework assignment on Thursday. I think when we first did that assignment, we only did non-keyed hashes like MD5, SHA-256, but we can also do keyed hashes. And it's kind of like an initialization key. So here you would just share with your friend this one, and that's it, okay? And then everything else should work. So we grab the blocks, 4 block in blocks, okay? And now what we're going to do is we can print. Now I printed the blocks. I just wanted to see the change. So you can do print block. So that just gives you the normal string, right, of 8 letters. Okay, you can also print the cipher block, and I'll talk about what that is in a sec. So print the cipher block. Okay. So this cipher block is the thing that we're going to get every time we take a block and XOR it with something, right? But instead of always using the key, now what we use is the cipher block that we get in an iteration. So in iteration 1, we get cipher block, and that becomes, like, let's say, the new key for the next iteration. That gives us a cipher block that becomes the key for the next iteration, and so on. Okay, so then we can do something like this. So I can, invokes assign to cipher block whatever encrypt gives me. So encrypt, is the function, right, that we already defined in our code. And encrypt would take a string of letters, right? So in this case, it would be the block, the current block, and it would take a key. But in this, instead of key, we use cipher block here. Do you see that? So every iteration, we get a new cipher block, which becomes the input, and we get a new block. And that's it. Now, of course, for the first iteration, we do need a cipher block, right? We need like an initialization vector, if you will. And what can we use for that? Do we conveniently already have something we can use? We have key, right? The thing that we're passing. So we use key just one time for the very first byte array. So basically what this means is we take the key in the very first iteration and the very first block, we pass them to encrypt, and that gives us a new cipher block for those two. Do you see that? Next iteration, we grab the second block, we pass that second block, and instead of passing the key, instead of passing the key, now we pass the cipher block from the previous iteration. And that's it. That does it. All right, so that's actually the whole, and this is what I had asked you guys to try to play with. So now that we do this, what's the final step? Oh, I didn't do this correctly, right? What am I missing here? 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. All right, what's missing here of this code?
Return statement.
Exactly. And what are we return? The final cipher block. The final cipher block, right? Because it's like, we have the first block and the key that gives you a new thing, and then we use that as a key for the next block, and that gives you a new thing, and then we use that as a key for the next block, and so on. So we're kind of XORing all of them. Got it? And that's it, guys. That's pretty much a hashing algorithm with XOR. And so now cipher block is what we print. And that should be it. All right, so now let's go back to the function should be done. So now we can go down here, and I'll add some comments so that I can add these in. So let me comment this out. Comment these out. Okay, so basically hash function returns this value, which is the hash value itself. So I can print that one out. So now let's go ahead, Control X, Y, right? Do clear. Run it. And as you can see, I'm printing all the strings and all the hexes as they're coming through. And then the final value is that. That's the final hex value. Okay, guys? Hash value, sorry, the final hash value. But it doesn't look as nice as OpenSSL. So then we might want to tweak it a little bit. So it's a little bit more consistent, and it's easier for you to email to your friend if you need to do so. And so I'm gonna do print, and I just grab that hash value, and notice I do .hex, and this just converts it to a more nicer format. So I'm gonna do something like this. And as you can see, it gives me this one over here. And that's hexadecimal, but it's more consistent with, basically OpenSSL. And then the last part, the kind of thing that I was trying to do the last time around is I wanted to do the binary, because we always did all of this by hand. When we did it on the binary level. So if you guys want to, you could use these functions to view the binary or to write this code and do the caret operation in the binary code, right? So I leave it to you. This is not a requirement. I may do this for another semester, but we'll spend way too much time if we go in that direction. All right, so but I'll show you the code. So basically all you have to do is, the trick is, we convert the hex, right? Hash value dot hex, and then we use this function int, and we tell it that it's 16 base because it's hexadecimal. So that converts it to integer, and then we can use the bin. If you remember, I tried to use bin last week, but I was missing this part, the int conversion. Okay, once you do that, it converts it to the ones and zeros. So, and there it is. And that's it. So that's basically the algorithm. So we've done two. We've done a substitution one, and we've done a XORing one. Okay. So this is also, I'm going to create a link for you guys to submit this homework. Just use a different sentence than the one I did, different length. You could play with, instead of 8, make it 16, whatever you want. Just make sure you know how to run these things. Now, you might say this is easy, but there will be a practical exam where all these scripts will come back. So make sure you know how to use them, because I may hide things using this script. And if you don't know how to use it, you will not be able to get that simple key of 8 letters that you need for another. This is how it's a scavenger hunt, right? Which means I've hidden things with different algorithms and different scripts, and I've given the stuff to you, but you have to know how to use it. Make sense? And at the end of the day, I'll hide a secret, like, the pass key for the Japanese when they attacked Pearl Harbor was climb Mount Netaka or something. Just those 3 words. I'll hide that message. I won't tell you what it is, obviously. So for you to arrive at it, you'll have to do a whole bunch of decryptions, and you got to understand all these tools, either with OpenSSL, Python, etc. Okay? So everything I will provide, so you don't have to really write code from scratch, but you will have to know how to fill in little things. Okay? Make sense? All right. So one example is, for instance, on week 12, when we do the practical scavenger hunt, I may have done an encryption for the hash that requires a specific key. So here you would have to know this key. You can't just randomly use one. It won't decrypt. Okay, so you got to get the right key, even if it's only 8 letters, and that may be hidden somewhere else. Okay, so it'll work like that. All right. So that's it as far as the script. Are there any questions? Nope. Pretty easy. Okay, so just as I said, make sure in your report you run it, you show screenshots, evidence that you got it to work and that you understand how to use these. Okay. All right. So that's it. So we're going to move to the slides. I have some slides for today. Okay, so I'll stop sharing.